calculus, we are going to do a few examples where we take the derivative of a function that is already given in terms of a natural logarithm. So on number 5 here, we're given y equals a natural log of the quantity 3x plus 4. And this is understood that 3x plus 4 has to be a value greater than 0, otherwise we can't even apply the natural log to it. So we're going to say dy dx is equal to, and the derivative of the natural log of u is 1 over u. So that whatever the natural log is being applied to goes on your denominator, and the derivative of this goes on the numerator. So this is a 3. So we just have dy over dx is equal to 3 over 3x plus 4, and we are finished with that problem. It's really set up for us really nice so that all we have to do is apply that one rule, that chain rule, and that was it. Okay, over here, I'm looking at y equals a natural log of the square root of 2x squared plus 6. So I know that I could do something like this, and I'm going to erase this, okay, so don't bother copying this. But I know that I could do something like this. I could say 1 over, and this is my u, which is the square root of 2x squared plus 6, and then the derivative of the square root of 2x squared plus 6 would be 1/2 times the quantity of 2x squared plus 6 to the negative 1/2 times 4x. And then I get kind of messy a little bit with this stuff. It's not that I couldn't do it, it's that I'm choosing not to do it, okay? We're going to take that square root out of there, and we are actually going to take a minute with the properties of logarithms before we differentiate. So y equals natural log 2x squared plus 6 quantity to the 1/2. And now the 1/2 can come down out in front of that natural log. Use your exponent property, bring it down in front, and you end up with y equals 1/2 natural log of 2x squared plus 6. A common mistake here is that people see a plus sign in between the two terms that the natural log is being applied to, and they distribute the natural log, which is totally wrong. Only when you have multiplication in here would you break your natural log up into two natural logs being added to each other. Addition doesn't break up, it's multiplication that breaks up. Addition gets put back together. Okay? So make sure we understand that. Now we're ready to take the derivative. So now dy dx is equal to the 1/2 just comes along for the ride. It's just one of the coefficients on the outside. And now I have this quantity that my natural log is being applied to, 2x squared plus 6, and its derivative on top, which is 4x. This is a lot nicer. I don't have the square root stuff. Even though that square root stuff would have worked its way out at some point, we're going to make it a little nicer by taking care of it with a leading coefficient. Okay, so my 2 here can divide into 4x, giving me a 2x. And on my denominator, I just get 2x squared plus 6, and I can say that that's the end of that problem as well. All right, let's see what I have for number 7 with you. I think we can fit 7 right here. I have y equals natural log, and I have this big fraction coming up here. So the sine of x divided by 3x squared times the square root of 5 minus x. That is just a mess right there. We have a lot going on. We definitely have a trig function, we have multiplication, we have our square root, which you see gets put into your 1/2 exponent and then brought down using your exponent rule for logarithms. So we're going to really break this up. The fact that we have a natural log in it already is really nice. I'm going to break this up and rewrite it first. This becomes the natural log of the numerator, sine x, minus the natural log of the denominator, which I'm going to take a step here, but I'm going to be kind of quick about it pretty soon. I'm not going to take too many steps very often. This is 3x squared times the square root of 5 minus x, like that. I'm going to rewrite 2 more times, because I don't want anybody getting confused with what I'm doing. Minus big bracket here. I don't know if you saw that natural log going up there. This is now a product of 3x squared and also the square root of 5 minus x. So I'm going to break this up into the natural log of 3x squared plus the natural log of the square root of 5 minus x. Now I'm hoping, and I'll close my bracket, I'm hoping you realize that that square root sign could have been written as an exponent right there. All right, let's just take our time and get it all done nice. This is the natural log of the sine of x minus the natural log of 3x squared. Now this square I cannot take to the outside because it's not applied to the 3x. If I wanted to break this up into the natural log of 3 times the natural log of x squared, then the 2 could come down out in front, but not as it is. I would need this to have parentheses quantity squared in order to bring the square out in front. Can't do that because the square is not applied to the whole thing. So 3x squared like that. Now I'm going to distribute this negative. You probably are thinking I forgot to carry my bracket here, and I suppose I could carry my bracket and then play with the 1/2, but I'm going to do these two in the same step if I may. This negative comes here. This square root symbol, you know, I think I will just always make it nice and neat for you guys. I'm sorry. This is natural log of 5 minus x quantity to the 1/2. I'll take it step by step for you. Now the 1/2 is going to come out in front. This will become natural log of 3x squared plus 1/2 times the natural log of 5 minus x. All of this is still in a bracket with a minus on the outside. I still have not taken a single derivative yet. All I've done so far is rewrote, and so on. One last step before my derivative. Natural log of sine of x minus natural log of 3x squared minus 1/2 natural log of 5 minus x. No more brackets. Now if you would like to go from step 1 to step 2, 3, 4, 5, or this is beginning step to step 1, 2, 3, 4, 5, all in your head and write it all out like that, I'd be very happy. Okay? I do not need to see all this detail. The detail I'm showing you is to make sure that we understand how we come up with this last piece. Both of these are on the denominator, both of these factors are on the denominator, and therefore both of these terms are being subtracted. The square root symbol is written as the 1/2 as the coefficient out front. And now I'm ready to take my derivative. dy dx equals sine of x is on the denominator, and the derivative of sine x is cosine x. If I wanted to be real sneaky here, what's cosine x divided by sine x? Cotangent x, we could write it as cotangent x. Minus, I copy my 3x squared down here. And what is the derivative of 3x squared? 6x. And then minus 1/2. 5 minus x goes to the denominator. And what is the derivative of 5 minus x? Should be a -1. This is multiplication in there. So I have room just enough to put dy dx equals on the bottom here. And I will go ahead and call cosine x over sine x cotangent x, just because I can. Minus the 6 and 3 will divide off and give me a 2. I'll have an x left on the denominator, so 2 over x. And then this negative, or this subtraction symbol with this negative sign is going to turn this into a positive 1 over, and I'll leave this as 2 times 5 minus x. Close my parentheses. This would be my final derivative where I choose to stop. And that is the end of number 7. I can fit number 8 right here, and then I will stop this video and I will move on to another one. Natural log of just 5x squared. And this is where you're going to get caught, okay? This is kind of like that natural log of 3x squared. I just want to pay close attention to this. If you break this up first, you'll be able to see natural log of 5 plus natural log of x squared. Only then can you bring this exponent down in front of that natural log. So again, I haven't even differentiated yet. The nice thing about natural logs is when you differentiate them, the logarithms go away. I don't have any logs throughout this work. And then this is 2 natural log of x. So now dy dx equals, the derivative of the natural log of 5 is 0. Because the natural log of 5 is a constant, has no variable in here. So this derivative is 0. Plus 2, and the derivative of natural log of x is just 1 over x. So dy dx is equal to 2 over x. And you might just prefer to go 5x squared in the denominator and a 10x on top, and you'd simplify that anyway, just like I did here, instead of breaking it up. Okay, we're going to stop this video. I'm going to come back. I'm going to do 2 more examples for you, and in that next video I will include the example 6 from your book in section 5.1. All right? Talent out.